we have another small update. So this system was technically built a long, long time ago. Before I even started this project, I had a school project to work on, and I made the system. Now, obviously, when I implemented into my own project, I made some tweaks to it. But today I had to rework it completely again. But it should be perfect now. And that system that I'm talking about is these three Boolean values here. Now, they, as you might have guessed, if you're a programmer, just enable and disable a bunch of code. So, to make to make testing easier, let's sync the detection range down to this much. Now, if I move the player here, you're gonna see, even though we don't have a direct line of sight, this enemy can still detect us and move towards us. That is because this is checked. Now, let's uncheck this one too. If you uncheck this, okay, one moment. And we uncheck back, going back to spawn. If you have watched the previous video, you would know what these do. And chasing the last known position, also uncheck that. Again, went over them in the previous video, so not really gonna explain them. I feel like their names also kind of explain what they do enough. So yeah. So now, see, we can detect the player because we have no line of sight within our detection range. Now, if you go back to this enemy and allow detection through walls, you can see we can now chase the player. But if we go here outside of the detection range, but inside to the kited range, as you know, the detection range is where we detect the player. But if they leave it while we have detected them, then we keep, knowing where they are, or we keep being kited to the player as long as they're within the kited range, as the name implies. So now, see, we cannot chase the player anymore. But if we kite the player, move out, go back here, enable stay kited through walls. Now, even if we don't have a line of sight, we can still remain kited. It's going to jump. Yep. Now, there's a sort of third layer of protection that the player can use, and it is hiding area. So any collider, trigger collider, so we can enter it, that is tagged as hiding area. Now, this, of course, would be like, I can't think right, like a drape, like since it's a castle, like some sort of banner, drape, something fancy, and the player would be presented behind it rather than in front of it. Right now, these are kind of just placeholders. Unfortunately, the sprite package that I purchased does not include any type of drapes, and I don't really have the skill set to draw uh, a drape tile set. Anyway, you will see now that we immediately, stop pathfinding, because we cannot detect the player. Now, if we check this, it means we can detect through hiding spots, even though within the hiding spot. Also, we have a debug draw. The red is drawing the collider of the player and then the collider of the hiding area. As long as we're more than 70% covered, the enemy will not be able to see us. So if we kind of just go out here, still mostly covered, mostly covered. Now, see, yep, there we go. We were no longer mostly covered and the enemy can see us. And as you saw, if the enemy and us are within the same hiding spot, it can pathfind toward us. Honestly, I kind of completely forgot about that feature. Wasn't even gonna name it. But yes, now this enemy, if we check and see hiding through, or can see through hiding spot, and it was already spoiled, as you can see, we can detect. Now let's do this. And as you can see, because we can detect through the walls, even though we can detect through hiding spot, we cannot find the player here. Um, so yeah, this is a pretty interesting feature in my opinion. Uh, and there's one more thing I'd like to show off. Now, this isn't really gonna seem cool for anyone who's a non-programmer, but our system is quite robust. As you know, if we're within the same hiding spot, we can sense the player. But if we're in a different hiding spot, see, we cannot sense the player. Now, let me just move this sort of closer. Yep, we can not. So that's something to keep in mind. It's a very good detection system. Before we relied on raycast, which is basically just a ray to see the player, but here we rely on a different method where we just compare the transform component. Now, if you don't develop with Unity, or I actually don't know, maybe other programs do use some sort of transform component. Anyway, in Unity, you can compare transform components directly to see if it's the same object or not. So because it's not, it's a copy of it, yeah, we can safely hide from the enemy here. And this can create some interesting mechanics, especially, again, as you know from the last video, we have all of these settings here. We have a lot of settings, really. So you can really create a very dynamic enemy system with all of these settings. Of course, I'm planning to improve it a little more. But the Pathfinder is going to be a Unity asset in the future, hopefully. So other games can sort of implement it for a fee. And also the detection system, although quite simple, might make it a cheap asset or a free asset. We'll see. I guess since this video is kind of short, I can continue rambling on a little more. My next goal would be, where's the manager? So this is the navigation graph for the test enemy. And as you can see, we cannot land on obstacles. But I'm hoping to improve it so that we can still pathfind if we're on the obstacles, but only like pathfinding away from them. So we'll have like a sort of a red node here to signify danger. And instead of going to the player, we prioritize getting out of or not being on top of danger nodes. Now, this might sound simpler than what it really is because we'll also have danger nodes without a collider, a sort of gas cloud or something along those lines. And also we have air enemies to account for and their nav graph, which I have not given any consideration to. I believe if we go here, yeah, it's not even generating one for them for whatever reason. That's a big issue that I will need to address later. But it should not be a problem at all. Air enemies are so much simpler than ground because they just float. There's no jumping, there's no gravity to account for. And yeah, that should be our progress for the day. Maybe even rework the drawing system, the one that I'm using here, to be less laggy because as you can see, if I zoom in and out, it lags compared to if I just not draw anything. And also, I'll need to rework it anyway to include the danger nodes. But honestly, the drawing system, that one is made completely by AI, completely vibe coded. It's not necessarily an important feature. And also, I was kind of too lazy to think about how to do it, but it's kind of simple. It's just if this is checked, it's using these flags. If this is checked, then only draw this. But if this, it's simple stuff. It's what you should give to AI, simple things. Anyway, that will be all.